Okay, these are the notes for topic 1.9, finding density of a piece of material. And so density is a proportion or ratio. The two characteristics that we look at for an object is the amount of matter or mass and looking at how much space it takes up or volume. So the more mass you have packed into a smaller volume or space is going to give you a higher density. So in this particular object, we are keeping, or these two objects, I really should say, we are keeping the space or volume the same, but we can see there's more mass represented by these atoms with the particle diagrams than here, giving this object a higher density. So we have an equation because we're going to talk about how to represent this from a mathematical point of view. And so we have that density is equal to our mass divided by our volume. Or we can use that D is equal to M over V. Let's talk about units real quick. Mass is traditionally shown with grams. Every once in a while, you'll find a textbook or a set of constants in kilograms, but grams is more frequently used. Volume has two options here, and this is why we spent some time with these conversions because we're going to see them again. Volume is traditionally measured in centimeters cubed if you are working with a regular object, meaning something like your textbook, where you can measure the dimensions of it. However, if you are working with a liquid, a gas, or an irregular solid like a ring or necklace, where you cannot directly measure its dimensions, we use a technique called water displacement, which would then measure in milliliters. So density has kind of two options right now: grams per centimeter cubed if you're using a regular object, or grams per milliliter if it's talking about an irregular object. So we're going to see that in some examples here momentarily. The last thing that I'm going to give you is a dorky way to remember the density equation. So I'm drawing a terrific heart and drawing a line through it. So density can sometimes be referred to as the broken heart equation. And so if you take a heart and draw it and put a slice through it horizontally, this top part looks like an M for mass, and the lower part kind of looks like V for volume. So again, that's a way to keep track of the density equation. So from here, we have a practice problem. So I'm going to show you what's the expectation for how I expect these to be solved. So it says a student finds that 23.50 milliliters, so this is volume, has a mass of 35.062 grams, and it's asking what is the density. So we know density is M over V. We're not doing anything different with our equation yet. So this part here is optional. I like to take my givens and pull them out of the formula, or the wording of the problem, I really should say. It makes it easier to work with. Everything that I'm showing after this point, so here, this is the first step I should see from you every single time. The next thing is substituting in with units. Units are key, so it's not just a number, but it's a measurement. So measurements include a unit. So this is step 2. This top value has 5 significant figures. This bottom one has 4. That means my final answer can only have 4. So when I divide these out, I get an answer of 1.492. No units are canceling like in conversions, so we get our gram per milliliter unit. This is step 3 with sig figs units for our answers. Okay? So again, this is what I should see from you at minimum. So like I mentioned with our units, sometimes we have objects where you cannot directly measure, and so we can indirectly measure the volume by using water displacement. So what you have is you start with a graduated cylinder with a measured volume of water. So we can see that it's resting at approximately 150 milliliters. You carefully submerge the object, and as you can predict, the water level goes up. So we have these long tick marks here going up by 10, so we have 180 milliliters. So water displacement, we don't care about the water itself, so we need to factor that out and look at just the difference in the two, or subtract them. So the volume of the rock would be 30 by taking 180 minus 150. So we're going to use that in this particular problem here. So kind of summarizing the top, we essentially have this student looking at a medallion, and we're trying to determine if it is pure platinum or if it's made out of silver. So these 3 bullets are what's important with a lot of our information. So she weighs the medallion and finds that it has a mass of 55.64. So again, like before, I'm going to start getting that information off to the side. And it says she places some water in a graduated cylinder and reads the volume as 75.2. I'm going to call this my V subscript I, or VI for initial volume. She then adds the medallion into the water and rereads it. And so this is our VF, or final volume. So in order to know the volume of just the medallion, you take your VF minus your VI. So we're going to take 77.8 milliliters minus 75.2, and the difference is 2.6 milliliters. Okay, so we need to find density so we can compare it to these two to figure out what is it made out of. So we have density is m over v, so much like the problem before, we're substituting in our mass 55.64 with 4 significant figures, and we have a volume of 2.6 milliliters with only 2. When we divide this, we get an answer of 21.4, or essentially 21 with significant figures, and nothing cancels. We get grams per milliliter. So you might notice something. The densities here are not using milliliter for the volume part. They are using centimeters cubed. There's a very important little conversion factor on your Holy Grail sheet. One unique characteristic for water is that if you have 1 milliliter of it, you have 1 cubic centimeter of it. It is directly proportional between the two. So we can just say that instead of 21 grams per milliliter, we could really say that it's 21 grams per centimeter cubed. Okay, so then the last thing is, do we think it's platinum? And it sure is. So yes, the medallion is platinum because the densities match. Okay. So on to the next example. So the last few kind of just have their own little quirks going on with them, different from the previous 2 problems. So it tells us mercury has a density of 13.6 grams per milliliter. So mercury, if you know anything about it, is it's a metal that is liquid at room temperature. It's the only metal that has that characteristic, but it's also very, very dense. So it's asking us what volume is needed to have 225 grams of this stuff. So that means in this first problem, in this next kind of section, is we are no longer solving for density, but using the equation to solve for other variables. So using our base equation, I traditionally like to rearrange my formula first. And I can tell you now, because we have essentially a fraction here with solving for proportion, and we're solving for volume, a lot of students want to move mass and keep volume on its own. If we do that by division, we get density divided by mass is equal to, and it's not just V, it's 1 over V, which means we have to deal with reciprocal, and we don't really probably want to go that route. So the best way that you want to go about that is when you start with your base equation, let me get all this off my screen, is that we have, there we go, D is equal to M over V. So the first thing I want to do is get V out of the denominator by multiplication of the V. So V multiplied by density is equal to mass. That is our formula if we want to solve for mass, but we don't care about mass right now. We care about volume. So the last step is we need to get density by itself, or not density, but volume by itself, by moving the density. We are currently multiplying, so you do the opposite order of operation, which is division. And so we get volume is the mass of the object divided by its density. And that is what we are going to use. So our mass is the 225, 3 sig figs. Our density is also 3 sig figs at 13.6. When we divide it out, we get an answer of 16.5. Go ahead and cancel those units out because they divided themselves out, and we are left with milliliters. So 16.5 milliliters of pure mercury will have a mass of 225 grams. So not a lot of volume, gives you a very high mass because, again, it's very dense. So on the back side, we have a few other things going on. So in this case, we have this block of granite. It tells us that it has a density of 2.7 grams per centimeter cubed. And it wants to know what's the mass, and that's all it gives us. But we do have this image, and so we can identify it as a regular object, meaning we can measure the dimensions, which is already done for us. So you probably can recognize that we can use our formula equation, our volume equation, not formula equation. So volume equation, length times width times height. So our length, 20 centimeters, times our height of 10, and our width is 5. And again, it doesn't matter what order you plug it into because you're just multiplying it out. So 20 times 10 times 5 is going to give us an answer of 1,000. We multiplied centimeters 3 times, so we get cubic centimeters. So that is now our volume. So when we start working this through, we are not solving for density, but we're solving for mass with our base equation. This one's a little bit easier than the previous one because we just want to isolate m. So to do that, we multiply v to each side to do the order of operation that is opposite. So we get volume is, let me backtrack, on its own. There we go. So what we really want is that mass is equal to my volume multiplied by my density. Substituting in my volume of 1,000 cubic centimeters. Density is 2.7. So my original answer is going to be 2,700. Centimeters cubed are going to cancel. Grams. This, however, only has one significant figure. So we can only keep the thousands place, so this is going to round. So my answer rounded to correct sig figs will be 3,000 grams for that regular object. Okay, last thing. This is going to be important for those of you that are in person. We're going to definitely use this with our lab. And so you can represent density with slope. If you remember from math class, slope is your rise over your run, y2 minus y1 divided by x2 minus x1. Well, we just said that density is mass over volume. If you take a look at the graph, we have mass on our y-axis and we have volume on the x. So if we look at the rise, the change in the mass over our run, the change in the volume, that is the density. So we need to pick 2 points off of this line, determine that mass and volume, find the change in the line, and that can tell us our density of the object. So looking at this line, you can pick any 2 points that you prefer, but I noticed this one here and this one here are very easy to read. So from that, we have 420 for my coordinates, and we have 8 and 40. The big thing you have to understand, though, and this is where we differ from math, is these are measurements. So notice we have cubic centimeters here for our volume unit, and we have grams here for our mass. So I'm going to start substituting in. So my Y2 is not going to be just 40, but 40 grams minus 20 grams. Because this was my Y2, this is my Y1. My x2 is going to be this 8, and it's going to be 8 centimeters cubed. And my x1 will be 4. So if you want to find the difference, we have 20 grams over 4 cubic centimeters. We can go ahead and divide that out, and we get 5 grams per centimeter cubed. So this is another way to find density using a mass versus volume graph. But in order for it to work, mass must be on the y and volume must be on the x. So then your homework assignment, use these notes to help fill in kind of any places that you may get stuck.